Welcome to Video 3A. In this video, we'll be discussing some properties of triangles, specifically mid-segments. So let's first of all go off over here on the right-hand side. And what we're going to do is define what a mid-segment is. I'll tell you what its two properties are, and then we'll go apply them to a couple triangles. So over here, what a mid-segment does is the word mid comes from middle, obviously, and segment comes from segment. So when I connect, let's go estimate the middle, what they'll do so that you're 100% sure it is the middle, oftentimes, is they'll mark these. That's showing those two are the same, so this dot must have been in the middle. They'll put 2 on another pair of segments, so you know they're different from your first pair, but equal to each other. And likewise, oftentimes they'll put 3 little dashes on here to show those are equal to each other, but not the same as the other ones you just drew. When I connect these midpoints, I get what's called a mid-segment. So I'm going to write A, B, and then let's maybe call this C, D, and E. So there's two properties that mid-segment holds. The first is that it always runs parallel to the side it's across from. They look parallel and they are parallel. So this always will run parallel to this. So we would say segment AB, it's called a mid-segment, will always be parallel to the side it's across from. And in this case, that's segment ED, or remember, we can also call that segment DE. Its other property is that its length is half the side it's across from. So if this over here is 10, the mid-segment would be 5. So the theorem actually says that AB, and remember when we're talking about how long it is, we don't put any notation with it. Without any lines or rays or segment notation above it, it means the distance from A to B will always be half of the side across from it, or the side it's parallel to. And this is actually called the mid-segment theorem. However, what I would suggest, so you might want to write a little suggestion down here. Instead of, and let's put a little star so you know I'm referencing that. Instead of saying that AB, 5 on this case, is half of DE, what's easier when you're doing the algebra ones is to say that longer side, so instead of saying the short one, whoopsie, instead of saying the short one is half of the long one, it's easier to say that the long side is equal to twice the short side, because it's usually easier to double things than to cut them in half. And really what I'm just saying here is that we could say that you're half my age, or we could say I'm twice your age. And algebraically, using the I'm twice your age is easier, because if one of them's 3x minus 4 and the long one is 7x minus 8, it's no fun to say that this is half of that, because taking half of 7 is going to give you a fraction. So it does allow you to avoid some mess with the algebra. So over here, let's draw this. This is called mid-segment. It is two things. It is parallel to, again, we need the segment when we're talking about the picture, RQ, and it's also half its length. So if I were to put some numbers on here, all right, let's suppose that this was 16. What do I know? I know this is 8. I actually also know these are 8 because that's a mid-segment, so it got cut in half, so I know lots of stuff. I also know you're running parallel to you. So let's go take a look at how this is done mathematically. So I know I'm dealing with a mid-segment here in this next picture. How do I know that? And the answer is because these are showing these are equal, so this is in the middle. I'm showing that these are of equal length, so that must have been in the middle. When I connect two middles, I get what's called a midsegment. I reference the side across from it. And this says to find the length of LN. So my goal is to figure out how long is LN. And what I'm going to do is say it is twice EF. So the long one, x plus 10, is equal to twice the short one. Again, the theorem actually says that the short is half the long, but I don't like to work with fractions, and neither should you, so let's go make our lives easier. So I'm going to go solve this for x with a little linear algebra. X plus 10 will equal 2x plus 4. I'm going to get my variable on the same side. I'm going to avoid some negatives here by moving my variable to the right, but you don't have to if you like negatives. I'm going to have 1x left over here, just x, plus 4. I'm going to subtract the 4, and I'm going to get 6 for my x, but that wasn't the question. So let's go over here. It said to find segment LN's length. So when I plug that in, I get 16. Now let's see if that holds. If I did my work right, this mid-segment should be half of this length. Well, when I go plug the 6 in right here, you'll notice I get an 8. So it looks good. Also, this runs parallel to this, but that wasn't asked. So that's our mid-segment theorem. Moving right along to another property of triangles, and it's called the triangle inequality theorem. And what this theorem states, and I already have it in here so you don't need to write it, is that the sum of the lengths of any two sides, so I grabbed that for you. So if I grab any two sides over here, let me go grab two of them, 5 and 3. Sum means to add the result after adding, the sum of the lengths of any two sides, let's say 5 plus 3, of a triangle must be greater than the third side. In this case, the third side is 7. If these are not true, you can't have a triangle. So it says any two sides. So is this true? Yes. 8 is greater than 7. So that's good. But that doesn't mean I have a triangle. I have to check that relationship between every pair of sides. So I'm going to grab two other sides on the triangle, 5 and 7. Is that greater than the third side? Well, yes, 12 is obviously bigger than 3. Then I'm going to go grab the other sides, 3 and 7, and see if their sum is greater. And yes, 10 is greater than 5. So this holds here, so I'd say yes, that can make a triangle. And you can see I made one. But what happens when that fails on one? Watch over here. Suppose I had the sides 2, and then I had 5, and then I had 1. And if I asked you, could those make a triangle? Maybe if towns were 2 miles apart, 5 miles apart, and 1 mile apart. Here's what I've got going here. 2 plus 5 is bigger than 1, so it holds. 6 plus 1 is bigger than 2, so that holds. But 2 plus 1 is not bigger than 5, so what that means is I couldn't have a triangle. Here's the problem with it. I've got one length of 5. Let's pretend this is 5 centimeters. The other length is like 2 centimeters, and the other one is 1. So I can't know, even if I try to push this in farther here, I'm still going to have a little gap over here. I won't be able to close the triangle until I make that other side big enough. Let's make, right? To stretch out, oh, that's still not big enough because it's got to be greater than. So let's suppose I made this. Let's go back to what I had this on. I had this a 2. Let's suppose I made that one a 4. Now I'm good enough because now this would, I could move the 2 in and the 4 would go down. So when you're checking to see if sides can make a triangle, you have to make sure that every pair of 2 outstretches the third, and they can't be equal. They have to be greater. So here's an example. Can 3, 4, and let's say 8 make a triangle? Well, let's check. Does 3 plus 4 outstretch 8? And I fail right away. So nope, can't make a triangle. What if I made this one 4? No, can't make a triangle. It has to exceed the third side. So one more pair. How about 5, 10, and 8? Let's check. Could I make a triangle out of those? Well, I run a check. Is 5 plus 10 outstretching 8? Yes. Is 10 plus 8 outstretching 5? Yes. Is 5 plus 8 outstretching 10? Yes. So I could make a triangle with these, but I can't make a triangle with those. So the next thing says, find the range for the third side. So what that means is, what could the third side be? Let's reword that so that it makes a little bit more, let's take the language. Really what this is saying is, what can the third side be? Now we're going to do this the long way, and then we're going to come up with a little shortcut. And I don't even like the word shortcut, because it's not. It's not like we're cheating and using a shortcut. It's really what I would call a smart cut. So here's a little demo. Suppose I had two sides that I knew and a third side that I don't know. In order for that to make a triangle, remember what I just told you with the triangle sum theorem. The sum of every two sides must exceed the third. So I'm going to set up 3 criteria here. 3 plus 7 would have to outstretch x. 7 plus x would have to outstretch 3. And x plus 3 would have to outstretch or be greater than 7. And what I'm going to do with these is solve each one for x. Over here, I'd get 10 is greater than x, or equivalently, x is less than 10. So I know for this to happen, x must be less than 10. On this one, I get what I call a garbage statement, because we can't have negative sides of a triangle. So this I'm going to check out. It's not helping me. On this one, I get x has to be greater than 4. So in order for my 3 criteria to hold, I've got to make sure that x is under 10. So watch, I'm going to tell you what the third side could be with an inequality. Here's the range or the possibilities for my third side. And see if you can see the relationship. Whatever that third side is, we're calling it x. It must be, go back over here, less than, it's pointing at the x, I'm eating the 10. So x is smaller than 10. I can't have it be 11, 12, 13, 14, 15. It's also greater than 4. So really what I'm telling you is x can be anything between 4 and 10. Now let's see if we can figure out the smart cut. Let's go back over here and see the relationship. The top boundary, 10, is actually what you get when you add these two numbers. The bottom boundary, 4, is what you get when you subtract these two sides. So really, our shortcut can be add the two side lengths to get upper boundary, then you don't have to set all this up every single time. It really makes it a lot quicker. So you add two sides to get the upper bound, and we subtract to get the lower bound. So let's do that really quickly. What could be the third side? Here's x. I'm going to add these to get my upper bound. I'm going to subtract them to get my lower bound, and I'm going to eat my way on up to the big one, and I'm done. How quick is that smart cut? It's pretty cool. Pretty awesome. Inequalities in one triangle is up next. We're on facts about triangles. Well, it's a fact that the side opposite the largest angle, and let's go see. Again, let's see what happens before we do it. I'm going to make a triangle. I'm going to make one angle that's obviously way bigger than the other, right? That's obviously the biggest angle, and that's obviously the biggest side. So the bigger the angle is, the bigger the opposite side is. It's like a pair of scissors. The more you open up that angle, the wider the gap is going to be for your scissors. So the side opposite the largest angle is the longest. And conversely, the angle opposite the longest side is the biggest. And likewise, same with the shortest. So the smallest angle over here across from it is the shortest side. And let's just put and likewise with the smallest. Fair enough? And we don't have to write it all out. This is an E. Oops. My E got a little carried away there. Sorry about that. I was just having so much fun making my L's, I got carried away with my E. All right, so let's see what the questions are going to look like. What they're going to look like is this. Let's move this onto my screen a little better. Let's order the angles from largest to smallest. Well, I don't know the angles, and I'm not going to go measure them with a protractor, and they kind of all look the same size. So how do I decide which one's the largest? I find the largest side, and I head across the street. So angle W is the largest, and it says to go from largest to smallest. Oh, lied. 20 is bigger than 19, Miss LaRude. Get out of town. That's crazy. So angle Y is going to be the largest. Then 19 will give me my middle angle. And it says to list or order. That means we separate with commas. And 17 is the shortest side. So angle X across from it will be the shortest angle. You might say, why are you allowed to label those with just one letter? And remember from an earlier section that if the angle vertex is not shared with any other angle, you can just call it angle X. It's only when we shoot off of there with a couple angles that we must use 3 letters. So a little notation review in there too, which is always nice. And then last up, name the longest and the shortest sides of this triangle. Well, I can't see the triangle, so I'm going to go draw it. It's angle DEF. E is about 80 degrees, so about, let's make it 80 degrees. And let's put E there. D is about 34 degrees, so let's go point and make a fake. It doesn't necessarily even have to be drawn to scale, but I'm trying to. And then I am unsure what F is, but remember the angles in a triangle add up to 180 degrees. So I'm going to take 180, I'm going to remove the 80, leaving me 100. Left over, I'm going to remove the 34 at the top. This leaves me 46 degrees. No, what's 100 minus 34, Miss LaRude? How about 66? All right, that gives me 66 degrees left over here for this one. And now those angles add up to 180, and I can easily see what the longest side will be because it's going to be across from the biggest angle. So the longest side is DF, and I'm talking about the side. So DF is the longest side across from the next biggest angle, so ED will be the middle length side, and across from the smallest angle over here will be my shortest side. And I'm done. So you will go do this worksheet, and let's say you only need to do the odds. See, listening to the video, if you just kind of hop in and do the worksheets, sometimes you're going to do some extra work. So we are done. Have a good one. Peace out, Girl Scout.